Alright. So as I said, the first thing you're gonna do is try to run over the stock from 5 in Trigs and see how much you remember, right? So number one, tan, right? I'll introduce these three one time, right? Tan is what? Tan was sine theta over cos theta, right? I want to introduce these one time. So when you see the old identities, I'll show you how to flip the same one time, right? Cot is what? Cot is 1 on tan, right? And if you put 1 on tan or 1 on sine and cos, you'll end up with cos theta over sine theta. That's all right? Cosec is something new. That's 1 on sine theta. And sec is 1 on cos theta. Right? So these three here might be new, right? Right from this, there are some identities I want you to remember. Right? The identities I want you to remember. The first one you should remember, you remember this one? Sine squared theta plus cos squared theta is what? Is 1. What is three lines mean again? These three lines mean equivalent, so you're not allowed to carry up with cos squared and solve. Only when it have two lines, you can solve. That's okay? Three lines mean you have to leave it as it is. Right? You don't have the ability to move across and manipulate. All right? Right, so we should know this. Cos squared sine theta cos squared is 1. And what would happen? What would happen if we divide everything by sine squared? What you'll get? If we divide everything by sine squared, you'll get sine squared theta over cos squared theta plus cos squared over. Sorry, I divide by the wrong thing. Let's divide by cos squared. What's this here? That'll be tan squared. What's this here? That's 1. And what is 1 on cos squared? Right? So from the old identity from form 5, we can get this. That's okay? Enough? Right? So this might be a little bit new, but I want to show you that it just comes from this. Right? What would happen if we divide by sine squared? Tell me what you will get. Divide by sine squared. What you'll end up with. Right? So you will end up with, you divide the same thing, right? You'll get sine squared on sine squared plus cos squared on sine squared, 1 on sine squared. This is 1. This is This is 1. This is cot squared. And this is cosec squared. Right? Again, a next new identity. Right? Again, a next new identity. I will do the double angles and thing later on, right? All right, so these are some identities I want to remember. Now, sir, we just adding these two identities. Right, so while we have the identities, let's try a few now. This way you get familiar with that person. Right. So you want to prove this, right? You want to prove this here, and you can choose any side you want, right? Remember, if you want, you can work with both sides at the same time, right? So you have an idea of what you want to get, right? What this is here? What's cosec by sec? What will this be? It will be 1 on sine multiplied by 1 on cos. So that'll be 1 on, right? Remember this? Cosec 1 on sine, sec 1 on cos, right? So your left hand side has to look like this. Try that now. Online, if you get it, just message QED. Try that in.
Yeah, I see.
If you left hand side, you should end up with that there, right?
Didn't know. I can't remember again.
That's not somebody forget how to do it, right? So left hand side is what? Cot is what? Cot is cosec, sorry, cos over sine. Tan is sine over cos. We have two fractions. We have to simplify it to look like this. So all we can do is find the LCM. Sine theta multiplied by cos theta. Right? And then this by this is this. Then cos by cos is cos squared. Sine by sine is sine squared. Right? Cos squared plus sine squared is 1. You can't stop here. Right? I just showed you what it's supposed to get. Right? So you can't stop here as the answer. When you reach here and these two equal, then write this and then this. So that's 1 on sine theta by 1 on cos theta, which is cosec theta by sec theta. And you have it. Now you can put Q. Right? Those stuff here. All right? You're not allowed to work on both sides, just one side. You're just working with the second side, the right hand side, to show you where you want to get. All right? So now that you're getting a little warm, let's do a hard one. Try this one. Take a time with the LCM part, right? Right? By now you should recognize that 2 sec squared is 2 sec squared is 2 on cos squared, right? Take your time when you're finding the LCM. And online, once you get your message on QED. Right, so let's check any way you find the LCM. This by this. Right, denominator is the product of those two. And your numerator is 1 minus sine theta by 1. 1 by 1 plus sine theta. Right? This by this is this. 1 by this is this. 1 by this is this. And then bring down the plus sign. Right? What would happen with the signs on top? Cancel. 1 plus 1 is 2. Then, if you look closely, this is difference of 2 squares, right? So you'll get 1 squared minus sine squared. 1 squared minus sine squared, you should remember that as cos squared, which is 2 sine squared. Yeah? Going again is just to get it back warm again before give it some harder stuff. Try this next one here. Oh, this one. But this is how I would have write it, but I might have written something like this. I would have written cut. I would have written cut divided by tan.
Yes.
Right? I'll leave the plus 1 there. I'll replace cut with cosine theta, sine theta, and tan is sine theta and cos theta. Then flip it. Right, but just don't forget the 1, right? So you'll get cos theta, sine theta multiplied by
Yes.
then you multiply this, right?
Yeah, but again,
Cos squared over
and then you use one of that fraction. I use one of that fraction and then.
1 over 1, okay, yeah.
And then find the answer. And then again, what is the take about fraction?
Right? So instead of writing it, you write it like this, right? Right? What would the LCM here, Adam?
So.
What would the LCM here be? And then what new numerator means,
That's possible.
right? And
That's not saying, okay, that's right.
what is cos squared plus sine squared? 1 on sine squared is. I got it all. What? Cosine.
So I do it slightly different. So from the start, I'm making one target that I'm making a shot.
Yeah, so you got 1 on tan squared, right? That is in. That could work as well.
I will say much.
Last one. This is 2016. This is 2016, right? What am I again? Should I stop now? This thing? Oh, no, remember, you're absolutely nothing before. There's a place to buy. So the guy is set up.
Yeah.
Yeah. How about you read my cards, right? One box. And the last one there, that would be 4 marks. Take a 10 minutes, simplify, right?
Yeah.
The time you will give me left or right? You multiply every 2-minute fraction of the same value. I think I'll be 75. You multiply every single 2-minute fraction. Like this. If you have A over B, I C over B minus D over B. If you have fractions like that and you multiply every single term by B, you'll get A over C minus. These two are the same thing. Right? You can multiply every single fraction by the same thing. Right? It's the same as multiplying by B on B if you want to look at it that. Right? So what can I multiply every single term by, Mikhail? What can I multiply every single term by? Huh? Sine theta. So multiply by sine, multiply by sine, multiply by sine. Huh? Why do we not? I'm trying to simplify it so you do have fractions and fractions. So I'm trying to make it look a little bit easier. So if you multiply every single term in a fraction by the same value, doesn't change it. Right? And hopefully it makes it easier, right? Time will cancel here. Time will cancel here. And you will get sine squared here. Right? What is 1 minus sine squared? Cos squared. So this is 1 on cos squared. Oh, which is sec squared. All right. Right, so that's a little warm up back into your identities. Of course, you to know all, right? Double angle, triple angle, right? We'll prove them later on. Right, now we can look at section. All right, so let's take a look at the graph of sine, cos, and tan. Let's take a look at the graph of cos. Right, we could always do cosecant, cos, and thing up, right? Right, but there are 3 graphs that we should know. I just put in them here, so I'll show you how to manipulate all, right? So the first graph is y is equal to sine theta. What was the shape of the graph again? Up, back down, right? Right, maximum value is what? Minimum value is? What's the period of this graph? How long does it take for one cycle? Period is 360, right? Actually, let's work in radians only. Let's work in radians only, right? 2 pi. Here's pi. That's okay? So you're writing here that the period is 2 pi. The amplitude or maximum value is 1. Minimum value is -1. What does the cos graph shape like? Same shape, you just ship it, right? How much you shipping in pi? I have pi, right? Pi on 2. So your graph will look like this. Max is 1, minimum -1, right? Same thing as this. Max is 1, period is 2 pi, minimum -1. Get that quick.
I do not like to be. You know what I mean? Yeah, so options. No, no, I have you ask and see if the answer matches.
You didn't have a baby before. Tan graph. How tan graph is what? Right? You have your asymptote at what? Pi on 2? You have your asymptote at pi on 2, and it looks something like something like that. Something like that. Something like that, right? Right, these are your asymptote lines, right? So these are the three main graphs that you have to be able to draw. All right, but what does happen? What happens when you see things like this? Right? What will happen if you see a graph like that? How do you sketch graphs like that? Suppose you see y is equal to 2 sine 4x plus 5. How do you sketch something like that? Right? So all you need to be able to get is the max value, your main value, period. All right? You got to figure out how to get those things. All right, so I'm going to show you how to get each one now, right? Right, so this letter A, that gives you your amplitude. That letter B helps you find period. Period is always 2 pi over. I need to know, right? Period is always going to be equal to 2 pi over that B value. And C represents your vertical shift. Right, so we need to figure out how to draw this. You figure out how to x minus n bracket x. And you want to hold on. Afterwards. I just do it. Ready? Take a look here and actually, I'm gonna give you a shift one time. Ready? So watch this here. I want to explain all the steps here for you, right? Of course, you can see A is 3, you can see that B is 2, and C is 4. Right? I just want to give you an idea of what's going on there, right? And let's be specific, we want it between we want it between 0 and 2 pi. Ready? Right? So the period is 2 pi and period is how long one cycle would take. This is one cycle here. For sure. I forgot to write that here for you. Right? Your max value is infinity. Your minimum value is minus infinity. What was the period of the tan graph? How long does it take for one cycle? This is one cycle here. How much? No, how long does it take for this to happen? Yeah. So it fit between here, right? So that's right. So a cycle for tan looks like this. A cycle for cos looks like this. A cycle for sine looks like that. Right? So period is how long it takes for that to happen. All right. So before we put it all together, I want to explain each stage, right? So let's start with 3. Let's start with 3. 3 represents the amplitude. So originally, the graph looked like that, right? And your max value was what? No, originally, the max value was 1. Right? Now, if I said 3 sine x, right? We're ignoring this, I'm just showing you step by step, right? 3 means that the amplitude is no longer 1. The amplitude is now 3. That's okay? Now, if I put a 2 in front here, what does that 2 change? That 2 will change your period. Period is 2 pi on, in this case, is 2. 2 will cancel and you'll get pi. So it means that one of this cycle will not take 2 pi anymore. It will take pi. That's okay? So between 0 and 2 pi, how many cycles I have? 2 cycles. Right? So what I drew here for you is the graph of 3 sine 2x. How do I draw the graph of 3 sine 2x plus 4? All I have to do now is shift the entire graph upwards 4. That's okay? What will change? The maximum value will now become what? And the minimum value will now become 1, because it's going up 4. Right? So 4 plus minus 3 is 1. So your graph will look like that. Everybody okay with that? And if I were to make it more complicated and add a little shift here, add a little shift, this will shift to the left, pi on 4. That's it. Yeah?
You also sketch someone.
Yeah, they could absolutely do that. Could. It's more in the older years, not really in the recent years, but they could ask it, but it's definitely a multiple choice. In the multiple choice, they would ask it this, which one is this? Right? So you have to be able to pick out all the things, right? Right. So how do we sketch it? Here's what you need. Right? Here what you need. You need a max value. Your max value is always going to be your amplitude, right? Your amplitude plus your shift. That's okay? So your max value is always the amplitude plus your shift. So that's 7. Your minimum value is what? It will be a minus amplitude plus your shift. So you'll get 1. Enough? You okay with that? Period is what? Your period, that formula didn't really change. That formula, your period will be 2 pi over b. So your period is 2. Sorry, pi. Your period is pi. Everybody okay with that? Last part. The last part is we need to get the equilibrium line. The equilibrium line in all our previous examples was 0. Right? Our new equilibrium line. Anybody can guess? Y equals to 4. Right? Because it's going up 4. So your new equilibrium line will be y is 4. All right? Instead of y is 0. So your graph now, you can easily sketch a graph. That's 0. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. That's the equilibrium line. Right? That tells me that my graph will start here, go up to 7, come back to 1, go back up. So my completed graph looks like this. This value here, pi. This value is 2 pi. That's the final graph. All right. So the things we need are maximum value, which is amplitude plus the shift. Minimum value is minus amplitude plus the shift. I could write that here for you, right? A plus C minus A plus C. Period is 2 pi on B, and your equilibrium line is always going to be C. All right? That's the way your final graph will look. Everybody okay with that? Let's try one for me now. Right, it's not really a popular thing for you to see, but it's something that you have to know, right? Because from this, we can derive all our solutions and things.
Yeah.
When we start to solve it. Sketch this. Y is equal to, I don't know where you go, 2 pi. Instead of 2 like per half. And let me send you downwards. Try that. What's that sound? Hello? You can't wake up now, boy. Yes, you up and then you want to sleep now?
It's easily spot on you.
Try number 2. What do you see guys here?
If I read this, if it goes to already.
Got done? Oh, yeah, gonna sketch it. I need one more. Sorry, sir. Right, so you should have your maximum value. Your maximum is 2 minus 3, which is minus 1. Your minimum value is -2 minus 3. Your equilibrium line is -3, it went down. And your period is 2 pi over half, which is 4 pi. Right, so I am not interested in what happens after 2 pi, because at the domain I give you, the domain is from 0 to 2 pi. So I don't want the whole cycle, I only want a half, right? Yeah, Joseph? I only want a half a cycle. So cosine, right? Right, so it will look something like that. Okay. Don't draw the equilibrium line, right? Don't draw the equilibrium line as a solid line, as a broken line, right? Don't draw as a solid line. Last one. I'm gonna give you one with a vertical shift now, with a horizontal shift now. And yeah, I'm gonna give you a turn. That's a good idea. Try this one, 5 tan x minus pi on 2 minus. This horizontal shift is where? To the right and to the left. Which one? Positive, so to the right. Right? Question. Will this pi change the shape of the graph? Because the max value here is what? Infinity. So you just stretch it a little bit, you can't really see that in our graph. So this pi has no effect. All you have to focus on is the horizontal and vertical shift. Okay, that's fast now. Fast. Right, I'll send you a little pic of the full second and get a graph. Right, stop me now. Stop. Well, yeah. Hurry up, last one. Last one there.
See, all right. Okay. Sure.
Right. Well, yeah, before I do that, right, I want to mention something here, right? If I were to draw what you're saying, I just watch for 1 minute. If I were to say solve solve sine theta is equal to half. sine theta equal to a half, right? Here's 1 and here's 0, so half is somewhere here. Normally you'll end up with how much solutions? 2 solutions, right? Remember that? First quadrant and second quadrant. I want to point out something here because I mightn't draw a graph, right? What would have happened if I asked to solve 3 sine theta, 2x is equal to 1 or something? Equal to a half. What you'll do? Right? What you may or may not remember is this, right? If I were to draw a half, that's somewhere here. Actually, let me change it to 5 or something. If I were to draw it here, right? How many solutions I end up with? 1, 2, 3, 4. Right? So I don't know if you remember in math, whenever you're solving functions like this, right? If the domain gets larger, you have to add 2 pi and add 2 pi. Remember that? Anyway, I wanted to show you on the graph, right? But I'll show you back again when you reach it. Yeah. Right. Anyway, what's going on here with this graph? We're shifting the graph downwards 1. So our equilibrium line is -1. What are we doing with the graph here? Period staying the same because the value in front of x is 1. But we're shifting the graph what? We're shifting this entire graph pi on 2. So now my equilibrium line will be here. My equilibrium line will be at pi. Let's say pi is here. Right? And my next equilibrium line will be at 2 pi, right? So how do I draw the graph? How do I draw the graph? So remember, I shift the asymptote here and I shift the asymptote here. Right? Could we see inside here? Inside it should be easy, right? Inside here it should look the same. What about here though? How will here look? Something like that. Something like this. So remember, all our intention is shifting the graph. Imagine what? Imagine pulling this graph pi on 2. Right? Underneath here you have something like that, right? So if I pull this graph pi on 2, this will now be here. And this will happen a little bit lower down. So I'm shifting everything pi on 2. So if I shift this pi on 2 to look like that, if I shift this pi on 2 to look like this, so our graph will look like this between 0 and 2 pi. All right. Are you okay with this? So that's the way you catch the graphs, right? Take a little 2 minutes break and then we're going back into solving single angles. Here we go.
We have some. Yeah, yeah. No, not like any.
Alright, let's take a look at solving two equations first. This is the easy part that you might remember from Form 5, right? Which one's positive in the first quadrant? All of them, right? So if you look at the first quadrant here, that's the first quadrant, second quadrant. third quadrant, fourth. There's your first, second, third, and fourth. There's your first quadrant, second quadrant, third quadrant, fourth quadrant, right? If you look at all your first quadrants, they're positive, right? So whenever you're solving, sine theta positive, cos theta positive, tan theta positive, right? Everything positive in the first quadrant. If you look at the second quadrant, you'll recognize above the x-axis, only sine positive, cos negative, tan negative. So all positive here. Sine positive here, cos negative, tan negative. What happened in the third quadrant, Nathan? Third quadrant. What you could say about sine, cos, and tan? And the others? Negative, right? So you're seeing it here, negative, negative, positive. Right? You're looking at the graph, right? And fourth quadrant is what? Negative, negative, cos is positive, right? So that's why you remember that. Right? Your calculator will give you values here. How do you get the values here? Second quadrant. Yeah, the minus. Pi minus theta. How do you get your values here? I. And to get your values here, your minus. Right? So there's some things to remember, right? Whenever you're solving shape of functions. Right, Keisha? Right? Remember all of them positive in the first, sine alone, and tan and then plus. Right? Right, so you need to remember how to find them, right? And what I was showing you earlier, if you had to solve a sine function in the first quadrant first here, you'll get two solutions. But if on the other hand, your graph looks like this, you'll end up with 4 solutions. Right? And because this is symmetric, you'll have to find a way to get these 2 answers. Right? This is 2 pi away from this. This is 2 pi away from this. So if you remember, you add 2 pi into it, right? But I don't want to do too much of solving today as well. Actually, I'll have to show you some of them. Yeah, I couldn't see any sound. All right. So here's what we're gonna do, right? For number 1 and number 2, yes, we have to solve them, but I want you to give me a quick sketch of each one in the domain they give you. So I want you to sketch sine theta between 0 and 2 pi. Sketch sine 2 theta between 0 and 2 pi. Do that fast enough. And then we take a look at solving it, right? But I'll schedule quickly with one. Right, so we're gonna try to solve sine theta equal to half. We're gonna solve it two ways, right? We're gonna solve it in normal way and a graphical way. Right? What does sine theta look like again? Sine theta looks like this, right? 2 pi, here's 1, here's -1. Right? If you have to solve something equal to a value, you want to solve it graphically, just sketch this, then sketch this and see where they intersect. That's all. Sketch the left and the right and see where they intersect. Okay? Here's 1, here's 0, so I'll put in half. So I'll put in a half or somewhere here. So we're going to get two solutions. We're going to get a solution here, and we're going to get a solution here. Right? Graphically, you could have read it off, right? But we don't have any graph paper, right? So sine inverse a half, when you work it out, you'll get pi on 6. All right? So watch this here. Here to here is pi on 6, right? Here to here, that distance is pi on 6. So what distance is from here to here? Remember, it's symmetrical, right? Here to here is pi on 6, so here to here is also pi on 6. So to get the value here, what we just normally do is take this value and minus pi on 6. Pi minus pi on 6. So that's where this formula came from. So you'll get pi on 6 by 5 pi on 6. So the answer here is 5 pi on 6. Right? So to get my two answers between 0 and 2 pi, all I did, I found sine inverse a half and I got this value here. To get the second value here, where the line cuts the curve, is pi minus pi on 6. Right? To get the value in the second quadrant is pi minus pi on 6. Are you okay with that? Are you sure? All right. Where you get lost? Right, so sine theta is a half. I move across the sine, I find sine inverse a half, and I got pi on 6. Remember, there's a positive value, right? So sine is also positive here. So to get the second value is pi minus pi on 6. What I was showing you here graphically, when I draw the line y equals a half, and I draw the line y is sine theta, where the line and the curve meet, that's the two answers. If you draw it graphically, but we just sketch it, right? Are you okay with that? What would happen here now? What does sine 2 theta? What does sine 2 theta look like? Adam, what does sine 2 theta look like?
Sine theta.
Yeah.
Pi. Pi.
What the graph will look like? What the graph will look like? Period is now what? What would the period be for 2 theta?
Pi.
Pi, right? So how many cycles will I get between 0 and 2 pi? How many cycles? Two cycles, right? Right?
I mean 4 parts. That's all.
4 parts.
Yeah.
So now the amplitude is still 1. So now if I draw the line y equals to half, how many solutions will I get? I will get 1 here, 1 here, 1 here, and 1 here. So I now have 4 solutions. Oh. So now we write sine theta is equal to sine inverse a half. And then we do the same thing as before. And we will end up with pi on 6 and 5 pi on 6. Are we okay with that? But this is only for the first 2 solutions. How do I get the next 2? Remember, this is symmetrical, right? So from here to here, how far is that? 2 pi. From here to here, how far is that? 2 pi. Right? So all we have to do now is to add 2 pi to 5 on 6, add 2 pi to pi on 6, and then 5 pi on 6. Are you okay with that? Right? So if you look at this carefully, this is a whole cycle later. So that is why to get the answer here, all I have to do is add 2 pi to this. That's okay? And we will end up with 2 theta is pi on 6, 5 pi on 6. This is what? 12 and 1, 13 pi on 6. And 13 and 5 is 18 pi on 6. Is that my final answer? No. This is 2 theta. I have to divide everything by 2. 12 and 1, 13. 12 and 5 is 17. All right? So your final, yeah. This is a yeah, you can see it. Plenty. Very confused about. Right? All I remind you here is to get all this solution. There's a lot more working. Right? I just want you to remember to get all these solutions. Okay? If you stop here, you're losing 2 solutions. Or here. Huh? How I know? How I know to add 2 pi is because of these cycles. This 2 theta, you want to know the graph in your head, right? But the next thing you can do is this. I can write it here. If I multiply everything by 2, what happens to the domain open up? So the domain doesn't stop at 2 pi. You have to consider now, how do I get the other value? So to get the other value, you just keep adding 2 pi. How you know it's 2 pi? Because graphically, this solution is 2 pi away from this solution. All right, so you know all the solutions they have here is at 2 pi. That's all. Right? If by chance you recognize that this value falls outside here, all 4 must fall in there. You realize that? All 4 falls in there. So technically, sometimes we keep adding, like if this was 3 theta, you don't have to draw it to figure out you're going to get 6 solutions. If you add 3 theta here, you know that going to 6. So you just keep adding 2 back until your last value falls outside of it. Right? If I add 2 pi to this again, outside here, so add 1. Right? So you can use that method as well. But graphically, you should be able to see it in your head. Right? Everybody okay with that? Right? So it's important you remember these last set of values, right? Copy it down and let's try one. You don't have to draw the graph. I just want to solve it. Right? The graph is just to show you how many solutions they ended up with. Too small. Too small. Guy number 3. Guy number 3 there. Take your time, make sure you find all the solutions, right? Right, done. Always pay attention to your domain, right? It could also be sorry, your range. It could also be 0 to 5. So pay attention to your domain, right? Why we doing that? Because we're gonna be domain a little bit now. So originally a solution was 0 to 2 pi, right? But now 2 theta is solving 4. So whenever you're solving 2 theta, it opens it up a little bit to 4 pi. So that's why you add 5. Then you want to 6 pi, so you gotta keep adding. Right, so as I said, doing the same thing again. So we starting here, 2 theta. 2 theta is cos inverse root 3 on 2. I could be wrong, but I think it's pi on 6. Pi on 6. And so your first quadrant value is pi on 6. And the cos is positive in the fourth quadrant, so that'll be 2 pi minus pi on 6. But remember the domain change, right? Keep saying domain, I mean the range change, right? So it's now 0 to 2 pi. 2 theta is 4 pi. So it means that this is not enough. I have to still add on 2 pi to all, right? So adding on 2 pi here, I'll get 2 pi plus pi on 6. When I add on 2 pi, I will get what? 4 pi minus pi on 6. That's okay? So it now means I have all the solutions between 0 and 2 pi. Sorry, 4 pi. So I have 2 theta is pi on 6. 12 minus 1 is 11 pi on 6. 12 plus 1 is 13 pi on 6. 4 pi is what? 6 by 4 is 24. So I got 23 pi on 6. But I get all these values, right? And now divide everything by 2 and you have your final set of answers. Pi on 12, 11 pi on 12, 13 pi on 12, 23 pi on 12. Adrian, Kevin, you okay with this? So it's important that you remember this, right? Yes, it's important that you remember your range you're working with. If it were 3 pi, then it's up to 6. And you get all your values. All right? Pay attention to if it's up to pi as well. A solution here must always fall in your range, right? Right, so that's kind of your intro back into it. Well, let me give you a quadratic. That's straight from form time. Let me see if you remember what to do.
I know. What? Yes. Right, this is some revision, just do over this sum it up.
Huh? With question? Yeah, that last one there.
It doesn't go away. It doesn't go away. That was not the one. I think it's a bit of Indian, right? They tried to set them in every place. No, I hate that one.
Right, just your last one there, we got. That's not four, five.
Yeah, what the? I should be. Ah, think I don't.
Yeah, but all that we got in the Catholic, right? So that's. In that called Catholic and in the. Right, so you might remember to solve it. We repeat cos squared with 1 minus sine squared, right? And now we have everything in terms of sine. Right, so now we end up with 4 sine squared minus 4 sine theta. Right, then you solve the quadratic. What you got? What you all got here? A half. And the next value is what? Minus 3 on 2, right? This has no solution. And this one here, between 0 and pi, that will be sine inverse a half. Same two answers. And here was minus 3 and 2, right? Yeah, so no solution, right? Yeah, then that was quadratic. And then so I use plus squared is 1 minus the sine squared. Expand it out and then solve this. Here, you just solve it and get your value first quadrant. All right, next one. What's that?